expression of electric field due to a dipole, electric field due to a dipole, electric dipole along the equatorial line of the dipole. Of course, here the dipole means the electric dipole only I'm talking about, of the dipole, also known as the tan B position, also called a brought-on position. In some books you will see this name, that's why I'm writing this. So now consider an electric dipole. Consider an electric dipole lying along the x-axis, right, with the negative charge, negative minus q on the origin. No problem, you can keep it anywhere you want to keep it. Origin. Now you see one thing. Or yes, you're keeping it on the origin, no problem. Now you have the figure here. This is your y-axis, this is your x-axis, this is your minus q, this is your plus q. Now it is from the center of this line, at the point here, you want to find the electric field. Let me draw the line clearly. Yes, this angle is theta, this angle is theta. This is a line perpendicular, exactly perpendicular. This is at a distance r from the center of the dipole. Wait, r from the center of the dipole, r. This is the point P. Now due to this, the electric field will be in this direction. It will be in this, and due to this, sorry, this is plus q. Due to this, it will be in this direction. Now draw a line parallel to the x-axis. Now this is theta, right? This is 90. This is 90 minus theta, so this is theta. If this is theta, similarly, this is what? This is theta. Now this is also, this portion is 90 minus theta, right? This portion is 90 minus theta, and you draw this line little up, it will be easier for you to find the value. This is 90 minus theta, and this is 90 minus theta, vertically opposite. So this is again 90, this is 90, this is 90 minus theta. See, this is 90 minus theta, this is vertically opposite angle. 90 minus theta, so this total is 90. This total, this line and this line is 90, so this is again theta. So you've got here, this is, let me write it clearly, this is theta. This is the electric field due to Q charge. This is the electric field due to Q charge. This is the electric field due to negative Q charge. This is the electric field due to negative Q charge. Now we will write everything. Consider the point P at a distance r from the midpoint of the dipole, from the midpoint of the dipole. Midpoint, this is very important, midpoint of the dipole. Now see one thing. Now this is r, this much is a, because the total length is 2a. By Pythagoras, sorry, let me write this clearly. This is 90 minus theta, let me write it clearly. This is 90 minus theta. Okay, this line and this line, this is nothing but, using Pythagoras, becomes r square plus a square. Now, the electric field at point P due to plus q is nothing but EQ is 1 by 4 pi epsilon naught q upon r square. Take the square of this. Take the square of this. So this becomes r square plus a square. Now the direction in this sense is, the direction, let us consider the direction in this sense. The direction in this sense is, say, the direction in this sense is, say, you can take this as eta n. The direction in this sense. Let me write with a different color. This is eta cap. The direction is eta cap in this direction. Right? Now you have to write the electric field due to at point P due to minus q. I forgot to write here plus q. Let me write it due to. Okay. Now the electric field here would be, see, E minus q would be 1 by 4 pi epsilon naught q upon, you have r square plus a square. Now in this direction, you take a vector, you take the vector in this direction as, you have taken this as eta. Now you have this as, okay, you take this as minus r. This is the inward direction, so the outward direction is always plus r. So you take this direction as r. This you take it. Let us call it some eta vector. You take as some other vector, some unit vector. Some unit vector you can take as, no problem. This is just a symbol. Zeta vector. Zeta vector is in this direction. Zeta vector, let me write it in the different color. This is zeta vector in this direction. In this direction. In this direction. Zeta vector is in this direction. Now, let us now try to write down this eta vector in terms of I and j cap. Eta vector, if you look at this triangle, I'll redraw the triangle here for you. This is your triangle like this. This is your x-axis and this is your y-axis. This was your eta vector in this direction. Now, see one thing. This is your theta angle. This is your theta angle. So your, and this is your I cap. Sorry, this side is your I cap. This side is your I cap. This side is your I cap, and this side is your j cap. Now the point is, see, eta is a unit vector. Remember this, eta is a unit vector. So eta can be written as cos theta, eta mod. Let me write it right. Eta mod cos theta. See, eta vector is in this direction. Cos theta. This will resolve in this direction, minus I cap and plus eta vector mod unit vector sine theta j cap in this direction. Eta will go in this direction, in this two direction, and mod eta is nothing but 1. So this will be now, I'm doing it vectorally. This will be minus cos theta I plus sine theta j. No problem about it. Now you have this vector. I'm talking about your zeta vector. Now, zeta vector is nothing but zeta mod of this cos. Now see, let's draw the figure first. This is our triangle. Now, this is our triangle. This is our, the figure went little bad. Now the thing is here. This is our, let me take a different color. This is our zeta vector. Now in this, you have this and this. This is your theta, right? This is your theta and this is the zeta cos theta. Zeta cos theta. Oh, wait a minute. I made a mistake here unknowingly. This is theta I cap. Cos theta I cap and then minus sine theta, theta vector I'm writing, yes, plus theta mod sine theta minus j cap, because this will be in this direction and this direction. These two are the directions of theta cap. These have been resolved along the x and the y axis. Now you see, so theta cap is nothing but cos theta minus cos theta, Yes, this will be minus cos theta I cap minus sine theta j cap. No problem. I need this to be substituted in this, Now see, so in ij in the Cartesian coordinate frame, this is in the some other frame. This eta and this xi are in some other frame. Now what I do is that put the values of this in this equation as I told you. इनकी value यहाँ पे put करते हैं. Let us put the values. EQ plus is 1 upon 4 pi epsilon naught Q upon R square plus A square. Now, eta vector, this I think it's eta vector only. Exactly, it's eta vector. This is this vector. And the value we know from here, it is minus cos theta I plus sine theta j. No problem. Now, E due to minus charge Q is 1 by 4 pi epsilon naught Q upon R square plus A square. This is minus cos theta I plus minus sine theta j from here, from sine theta j. Now vectorially adding, we will have the net electric field at Q, net electric field at Q is E equal to EQ plus E minus Q. Just put this vectors, vector addition, just put these two values. These two values here. Let us now put them. You have E equal to 1 by 4 pi epsilon naught Q. Then you have minus cos theta I plus sine theta j upon R square plus A square. Then plus, wait a minute. Okay, sorry, just a minute. I made the bracket in a wrong sense. Wait a minute. Yes, now it's okay. Plus 1 by 4 pi epsilon naught Q. Now you have this as minus cos theta I minus sine theta j. Now see upon R square plus A square. Take whatever common is. Take all the common things out. You have this vector. E vector 1 by 4 pi epsilon naught Q. R square, A square also you take common. Now what you are left with, minus cos theta I plus sine theta j minus cos theta I minus sine theta j. Cap, all cap, oh sorry, this is this one. This and this cancels out. What you are left with, E equal to 2Q minus cos theta I upon 4 pi epsilon naught R square plus A square. This you are left with. Now see what is cos theta. Let us see what is cos theta from this figure. This is our cos. This much is our cos theta. This much. So cos theta is base upon hypotenuse. Base upon hypotenuse. Base is A and hypotenuse, you know, under root R square plus A square. Under root R square plus A square. So we will write it here. It is equal to minus Q A I upon 4 pi epsilon naught R square plus A square, and an R square plus A square to the power of half, that is under root this. Now we know electric field P is directed electric dipole moment, not electric field, sorry, electric dipole moment, moment is Q into 2AI. Why? Because electric dipole is always directed from the negative charge to the positive charge. So it is in the direction of the x-axis, in the direction of positive x-axis. So you have this QAI. So if you look at this thing, if you look at this part, then what you have is, just a minute, yes, you have this. So your E becomes minus P, because this whole portion, this whole portion, this whole portion is nothing but Q. This P upon 4 pi epsilon naught R square plus A square to the power of 3 by 2. Now here, in this case, electric field is opposite to the direction of electric dipole moment, right? So here in this case, if you see, if R is very, very much greater than A, then R square minus S plus A square tends to R square. This is the thing. Now put the value of this electric field here. Now you see, E is equal to minus P vector upon 4 pi epsilon naught R square to the power of 3 by 2, and this is nothing but minus P vector upon 4 pi epsilon naught R cube. So here E is inversely proportional to R cube. Now, of course, I told you that the graph for this is E by R is somewhat like this. Smaller classes, instead of, in class 12th I mean to say, you didn't use this vector form. You didn't use this vector form in order to cancel things. What you did was that, जो किया था क्लास 12 में ऐसे वेक्टर फॉर्म में नहीं किया था, ऐसे करके वेक्टर फॉर्म पे कैंसिल नहीं किया था, ऐसे वेक्टर फॉर्म में कैंसिल नहीं किया था. What you did in class 12th was that you wrote that this, see the figure, that the perpendicular components cancel out, then the parallel components add up. What you did in class 12th, you said that the perpendicular cancel, this perpendicular component due to this, and the perpendicular component due to this one cancels out, and then you wrote it. It is better you do it in the vector form. It's very simple. This is so this is something different. Class 12 में क्या किया था, इसका perpendicular component, wait a minute, इसका perpendicular component, इसका perpendicular component को इधर और इधर cancel कर दिया था और लिख दिया था कि यहाँ पे 2 ये है, without vector form, without using any vectors and in this. But the right approach is using vectors. So I have done it in vector form. In class 12, you people had said that the perpendicular component of this and the perpendicular component of this cancels out here and here cancels out. This two cancels out. Only this and this component at this, the parallel components add up. The perpendicular component cancel out. It is better to write in a vector form because you are doing physics कर रहे हो, vector form होना चाहिए जहाँ पे wherever possible. Especially in this derivation, vector forms are better you do it in vector form. See, that's why I made you understand how this eta is. See this figure now. Eta is in this direction. Eta is a unit vector. One cos theta and one sin theta. That's why I had written this eta mod and eta mod. And what is eta mod? Eta mod was nothing but similarly zeta mod. Similarly, your zeta mod. This is same as zeta mod. Wait a minute. This is same as zeta cap mod. This is same as this. They're all unit vectors. The magnitude is 1. That's why this was 1. That's why this was 1 and this was also 1. Similarly, in this case, this was 1 and this was 1. You are trying to resolve this. You are trying to resolve this eta component 1 cos theta. See, I'll show you. This is 1 and this is 1 cos theta and 1 sin theta. Similarly, in this figure of zeta, this is 1 cos theta and this is 1 sin theta in this direction. So this is 1 sin theta in this direction and 1 cos theta. And though it is in the negative sense, so it is this minus sign was there. This is the thing. You can write that way also, but that doesn't look good now. You should use vector form. This vector form, you must know how to use vector form. Vector form will help you in many derivations, making things easier for you. In the beginning, it may look very cumbersome. पहले बहुत मुश्किल लगेगा देखने में. थोड़ा सा आदत कर लोगे, little bit of practice and you will be fine with it, and you will be fine with this. Okay.